Okay, so this presentation itself, it contains just the case study. So I believe it requires a little bit of context to explain what really changed compared to how SNMP was being monitored previously. So at previous versions of Zabbix, SNMP each item gets one item individually. That means that for most of the time, you'll be connecting to the device very often for a little amount of metrics. Okay, and not all devices are that fast, and this can become very slow, and in certain cases, dramatically slow, which will actually be this case study I'll be talking about. So in 6.4, a new feature was introduced, a completely different approach how to do SNMP monitoring. Instead of those individual items, we now have the ability to create one item that collects absolutely all, or maybe almost all information that we need. And it does that much more efficiently because under the hood, it uses SNMP bulk walk, which in reality is much, much faster. Okay, and then in one item, we get a lot of metrics. And I was also a bit worried, how will this scale on very large SNMP devices, but it does, as this case study shows. And then we've introduced a couple of new pre-processing steps. SNMP walk value that is supposed to be used on a dependent item and extracts one specific value by matching exacto ID. And also it can be used for low-level discovery. So dependent low-level discovery, where again, we have a pre-processing option, SNMP walk to JSON. Okay, and before this was even introduced, I already had an idea that this would really, really help this one customer for whom SNMP performance had been a very huge issue. Okay, so this is what this case study is about. Okay, so first a little bit of background about that customer's environment. So initially, this was a turnkey project by company Zabbix. So we introduced this and set up this environment. At the moment, we planned something about 10,000 new values per second, so not a very big installation. We already knew that we are going to do basically only SNMP checks there. And at that moment, the LTS version of Zabbix was 5.0. And by calculating amount of devices, locations, and everything, we had planned for 10 proxies. All the proxies also were set up in high availability, as was Zabbix server. Okay, and after a while, when everything was actually introduced, this is what we ended up with. So about 14,000 devices and 12,500 new values per second. But they had a major problem. SNMP was just dramatically slow there. Okay, we introduce proxies, we start monitoring hosts, pollers become 100% busy. We start more pollers, still 100% busy. Start more, okay, maybe no, okay, but add some more hosts, again, 100% busy. Until we pretty quickly used all of our 10 proxies and they were all just 100% busy here. Okay, it wasn't really a problem of resources. Those pollers were basically just waiting for SNMP to respond, and it was doing it very slowly. Okay, so I had an idea at the time. We should just start more pollers. 1,000 was the maximum. Let's start more. Okay, it would have helped, but luckily we introduced this new feature, and this is basically no longer required. So this probably will not get implemented, at least not for that reason. So the process that we went through. Considering how many hosts are monitored, I evaluated we should start some 100 pollers on the proxies. Add some hosts, add a bit more hosts, 100% busy. Start more. Okay, again, add some more hosts and more. And again, 100% busy. 1,000, still a problem. And they had not even set up all of the hosts they wanted to monitor. So we started investigating. Some hosts were also timeouting often, and they really were responding that slow. We ended up increasing timeout to 20 seconds. And this, of course, did not help in polar busyness. We often saw in the output in the command line, got 5 values in 20 seconds, 16 values in 20 seconds. Those were kind of the worst use cases. But in reality, it was averaging around 1 value per polar per second. Okay, and that is just dramatically bad performance. Now, why it happens that way, I can't fully explain. One reason is, okay, the devices are busy. They are doing their main work. If it's a switch, it's doing its work. If it's a router, it's also doing its work. And SNMP is not the highest priority, which is probably correct. But still, we need that data, and even that networking team managing those devices, they need those values, they need them monitored. Okay, so the reality at that moment is that polars are often this busy. They hit 100% busy and are actually so overloaded that they don't collect all the metrics that we require. A graph like this is a sign of very, very bad performance. Okay, yeah, so what to do? We can't start more polars. Let's add more proxies. That is always a solution. Okay, so initially there were 10 proxies. We increased it to 20, and still that is not enough. Okay, so what to do next? More proxies? Well, they no longer really want to add more proxies. We had lots of ideas. Okay, let's use the same hardware because there's a certain set of hardware they use for proxies. Let's just use the same hardware and run multiple instances of proxies there. Maybe just run custom binaries with custom config files or run them in containers, etc. But this too was ruled out by the customer, by their system engineering teams. They did not want to do that because complicated to maintain and other reasons. Okay, this had been working already for a while, so the customer itself came up with not a bad idea. So proxies are working in high availability. That means there's 2 hosts dedicated for each proxy. But they seem to be very stable. Nothing had ever happened to any of the proxies that they would actually need to fail over. And if one proxy actually breaks, they decided it's not such a bad idea. So let's break up those proxies. And now instead of 1 proxy, we get 2 proxies. Okay, great, problem solved. And about this time, the situation kind of stabilized. Okay, we were most of the time collecting most of the data with 40 proxies. But again, it was a lot of work to manage all of this because not all devices are as slow as the other ones. We never really know if we put these 5 new hosts on this proxy, will it overload it or not? First time we put 5 hosts, everything is fine, no change in polar busyness. We put 5 more, suddenly it is 100% busy. And even the proxies that are working kind of fine, the situation is changing. I guess the load on the devices is changing. Some device which was not as busy before and worked faster now became slower. And basically, they had to constantly take care of this. Juggle the hosts around the proxies and try and figure out some kind of a solution that works for that moment. So, not great, but at least works. Okay, so 6.4 came out. This new wonderful feature of SNMP bulk processing. Okay, we did not move to it immediately as it came out. We waited a bit. Maybe some bugs should be resolved. There were some bugs, but yeah. But we were planning for it. They also needed to upgrade the database. That was an internal requirement. They needed a different version, which was now standard in that company. After they finally did that, we upgraded Zabbix server to 6.4. And initially, nothing changed because with existing config, it just continues to work the same way. So to start using this SNMP bulk data collection, we need to change the templates. Okay, so previously we have a template. If you work with SNMP, probably you've seen this. There is a discovery rule, and it's doing SNMP walks on all of these OIDs, getting the values, deciding what's there, creating items and triggers out of it. Okay, this still works the same way. You don't need to worry that we'll make you use some new feature in case if you just upgrade. No, old approach is still working. Okay, but then how does the new work? So we create a new item type. Well, type is actually still the same. It's SNMP agent, but in the OID, we have a new syntax available now. Okay, so just the string walk, and then in square brackets, one or comma separated list of multiple OIDs, but without an index or even on a higher place in the OID tree. Okay, and it would basically do an SNMP bulk walk from that position to the rest of the SNMP tree. And output from it is something very similar that you see if you do it in the command line. Do an SNMP bulk walk or SNMP walk, output actually will be the same. And you'll see a list of lots of OIDs, maybe some even explanation about them, and a value. Okay, so what we do in this case, take exactly this output and return it as the item's value. Okay, so this is what such an item looks like. There is this OID entry walk, and in this case, two OIDs that we do the walk on. And output will look something like this. Okay, so what to do next? We need to create these dependent items, dependent discovery rule and dependent items. So that one item getting all of it is defined as the master item. Some item key doesn't matter. This is a dependent item. It doesn't care. And important part, pre-processing. Okay, and then this new SNMP walk value pre-processing step where we define the OID we are looking for. Okay, and that extracts the value we want. Add any other pre-processing steps if this metric requires, etc. Okay, but moving existing hosts, existing templates to this new feature required some work, but not that hard actually. If we want to just get one-to-one what it was previously, what it is now, it is some work, but not that much. So basically what I do is I go into the template, start with the discovery rule. Okay, in reality, I checked through all the OIDs that might be used here, try to find some common position from which to do the SNMP walk from. So I open the discovery rule, find the OID, I open the item prototypes, find the OIDs used there. Basically, I put them together and found, okay, this is the OID I want to start my SNMP walk from. Okay, then I do a full clone of the existing template, so I don't want to modify that one. I clone it completely and modify the clone. And we decided to just add the term in capitals walk to the new templates to be able to recognize which ones are the new ones. So item SNMP walk with this OID. Then I go into all of the items, all of the LLD rules that will be using it, just switch it from SNMP agent type to dependent item, and go to pre-processing SNMP walk to JSON for LLD. Okay, and define SNMP value we'll be getting from this part. And basically it is the same part. Here I just don't see the whole OID. The field is not big enough, but it is the same one as I used previously in discovery. So actually I open that rule and just copy this, change the types and go to pre-processing. Okay, also very important here, we don't want to execute LLDs too often. Therefore, it gets a value whenever the master item gets a value. Now, I don't want it to execute LLDs that often, so discard and change with heartbeat, but after this first step, because previously I still had actual metrics in the output, so there it would change often. Here, the things that I look for discovery might be more than one, but still, those are pretty static in most cases. So discard and change with heartbeat, so it doesn't execute that often. Then, for the items themselves, again, I open some item or item prototype and copy the OID used in it exactly, then switch it to be a dependent item, even key remains the same, and pre-processing step, SNMP walk value, and paste that exact OID here, with the LLD macro also here. Okay, after doing this to all of the templates in use, there were quite a lot, but we started with some 20, which were used on more than 90% of the devices. Now, we go to the device, to the host, click unlink, not unlink and clear, but unlink so that the items remain on the host and we keep history. And link this new template. And now those items are relinked to the new template. It recognizes them by the keys and just change their config. And now it starts working according to that new configuration, new SNMP bulk walk. Okay, and at this moment, yeah, let's hope for the best. We tried one host, it works, okay, but no real difference in how fast it works. One host doesn't show that. But when we started moving more than one host, initially on one proxy, the worst one, this happened. Okay, so remember that same ugly graph previously. Pollers just enormously overloaded. This is a picture we saw after that. Okay, some more examples here. We started decreasing the amount of pollers because we no longer need 1000. And one thing that I was worried about if pre-processing in Zabbix will not get overloaded. Now, one more thing we introduced in 6.4 is much more efficient pre-processing. And basically, I saw no difference in how pre-processing worked after this. Okay, so really good results. And the most important thing, queue. So metrics that had not been collected previously. So we see here it's around almost 150K constantly on that proxy. Then it went down. Okay, some hosts might have some problems, some couple hundreds metrics in the queue. Compared, that is basically nothing. And well, then having tested this on one of the proxies, we decided to move forward and do it for all of the proxies. And after that, I created one graph to show the situation. I call this the cardiogram. Okay, this huge drop here, this is polar busyness on all the proxies. This huge drop here is when we basically linked the new templates to like 90% of the hosts. Then again, we started decreasing the amount of polars, etc., and try to normalize that situation. But this is what we ended up with. So overall results are really, really good. Okay, this is kind of an edge case. I have never seen SNMP perform so bad anywhere else, but that doesn't mean that it won't help everyone else. Pollers will be less busy. It will work more efficiently. Okay, but not everything was so absolutely perfect. One thing that we noticed was memory usage increase, which is kind of expected, but I hoped it would not increase that much. But it did, okay, quite noticeably, almost twice. And as far as I understand the causes, well, no, I know the cause is unreachable pollers, and I talked with developers, but it all ended up with the fact that there will be some more major changes in 7.0 that should also fix this. So basically, we did not investigate much further. By decreasing amount of polars and unreachable polars, again, we normalized the situation and we were fine with that. Okay. Also, some bugs were found. If we find a specific interesting value null in the output, this could break something. This was quickly fixed. There were some more bugs. Okay, this one, as far as I know, is partially fixed. Okay, but it's an edge case specific scenario, so when that happens only, so I'm not too worried about this. And yeah, overall result, the installation is looking good, working fine, and we no longer need to constantly worry if we're collecting all the data, if everything works fine. It does now. Okay, that's all from me.
Okay, thank you, Edgar. So we do have a couple of questions. So let's see. The first one is, how is the HA set up for proxies? I assume not natively, since we're not on 7.0 yet.
Corals in pacemaker.
Okay. If you
It
have any,
was it was
go ahead.
also on the server.
So if you need any more details, feel free to use the Q&A section. Edgar's will probably stick with us for a bit and then answer in more detail. Will there be updated templates available for many of the built-in templates that will use this new walk method?
Simple answer is kind of yes. Some are already, but it takes some time and work. So I know for sure that all of them have not been updated yet, and we're supposed to be working on it. Some of them have been updated, some not yet.
Yeah, that's
But
also the
in
same
general, yes.
information I have. Yeah. I know the integration team is working on it and slowly trying to push out templates that use this new approach. Another more general question. So a person is saying that they have routers in dormant mode, so they have to wake up first before we can reach the device behind it. How can that be handled? The person says that they're wondering if before the bulk SNMP get is passed to the device, it check if the device is responsive?
No. But okay, first, I think that has nothing to do with this new feature. But yeah, the way it works is it will just try to run SNMP bulk walk and connect to the device, and then it either responds or it doesn't.
So I guess one way would be to just somehow script around it or use scheduled checks to wake up the device before you do SNMP data collection or something like that. Okay, and that's all. Thank you, Edgars. We can move on to our next speaker.